BGP or Border Gateway Protocol. In this video, I'm going to talk about the fundamentals of BGP, and in the future videos, I will talk about the configuration, concept, and other useful features of BGP. You know that BGP is a routing protocol, but a different type of routing protocol. In the real world, we have two types of routing protocols. Some routing protocols are IGP routing protocols. IGP means Interior Gateway Protocol. And some routing protocols are EGP, are in the category of EGP or Exterior Gateway Protocols. Okay, what is the IGP? What is the mean of IGP? IGP means the protocol is working in the intra of an AS. Intra-AS routing protocols. For example, you know that we have some IGP protocols. Maybe you remember RIP, OSPF, or EIGRP, or ISIS. And some other routing protocols are working between AS, inter-AS. For example, EGP and BGP. We have also IGRP, an expired routing protocol, as IGP protocol. Okay, RIP, OSPF, IGRP, EIGRP, ISIS are intra-AS routing protocols, and EGP and BGP are extra or inter-AS routing protocols. Okay, you know that an intra-AS routing protocol should learn and update the routing protocols, the routing tables inside of an AS, an autonomous system. But the inter-AS routing protocols such as BGP should complete and should update and should learn the routing for inter-AS or the routing tables for inter-AS routes. And after that, EGP, that is an old routing port, an old exterior gateway protocol, is an expired protocol. EGP now is expired and we can't use it. Expired routing protocol. It has many shortcomings. For example, it is a classful routing protocol, and you know that all of the networks now in the world are classless. But BGP is a classless routing protocol or inter-AS routing protocols. BGP, Border Gateway Protocol. Okay, in this course I want to talk about BGP and many features about the BGP. Let's talk about BGP. BGP, as I mentioned before, is a routing protocol for routing between networks. Okay, BGP between ASs, inter-AS routing protocol. And also BGP is an open standard routing protocols. This means that BGP is not a proprietary protocol, for example, such as all the EIGRP. Okay, the EIGRP now is not proprietary, but before 2013, BGP or EIGRP is a proprietary routing protocol, is a Cisco proprietary routing protocol. BGP is an open standard. The current version of BGP, we are using it in all of the networks, is BGP version 4, or maybe you see BGP v4. BGP is an application. BGP uses TCP as transport protocol and use well-known port of 179 Okay, BGP is an application such as, for example, Telnet, for example, SSH, but the BGP's function is routing, is advertising routing update, but it is an application with well-known port of TCP 179. It's so easy. And again, if we want to talk about BGP and globally talk about BGP, BGP is a advanced distance protocol. Okay, BGP is advanced distance protocol, or in some cases maybe you see this title for BGP, pass vector. You will understand the difference between the distance and pass in this course, but BGP can be named advanced distance vector or pass vector, advanced distance vector or pass vector. Okay, BGP is a modern protocol and has many features that we will talk about, all features about the BGP in this course. Now I want to talk about globally about BGP in this video, and in the other videos I will show you many details about the BGP. The first things I want to show you is the mechanism of BGP and some terminology in BGP, for example EBGP, IBGP, and some other terminology. I can use this scenario. Look to this scenario. For example, we have R1 and then R2 and then R3. Okay, this is a scenario, this is a network, and I want to use 3AS because BGP is a routing protocol between AS. Here R1 is an edge router in a network, in a company, in an AS. R2 and then, for example, R3. Look at here, R1, R2, and R3. Okay, and we have 3AS. R1 in AS 65000. It's the edge router of AS 65000, and then R2 in 65001, R3 65003, or maybe it's better to use these AS numbers. Okay, very good. Now, when you have BGP connections between the routers, BGP sessions between the routers, we call it BGP neighborship. The process of advertisement of networks between routers is the same process as at distance vector protocols. Look at here. For example, I want to send net A, one of the R1 networks, to R2 and then to R3. You know that in distance vector protocols, we send this address with some parameters, for example, metric parameters or non-metric parameters, to the neighbor, and then neighbor should send this address or this prefix to the other routers. This is the same function as it happened in the BGP. But in BGP, we use a special form of message. Look at here. An update in BGP, let's do it here. An update in the BGP routing protocol has some parts. The most important parts in the BGP update is two parts. BGP update. This is a BGP update message. I will show you all of the details of the message of BGP, but for now we have a BGP update. A BGP update has two most important parts. The first part is the NLRI. NLRI, the abbreviation of Network Layer Reachability Information. NLRI, or Network Layer Reachability Information, is the network that we want to advertise, network and mask or prefix that we want to advertise. For example, in these networks that we want to advertise net A, for example, 1000/24, this is net A, okay? This is our NLRI. NLRI means network layer reachability information. It's so easy, means the network that I want to advertise to my neighbor. And in every update, BGP update, we have NLRI or network layer reachability information. This is the first part. And the second part of most useful information in BGP update, in a BGP update, are PAs. PA means pass attribute. The attributes of the pass. I will talk about many attributes in this course, but for now, I want to introduce one attribute, one pass attribute to you, because I want to show you a simple example. For example, one of the pass attributes, we are using it in BGP, is the AS pass attribute. AS pass attribute or AS pass PA shows us the pass of ASs that the packet travels among them. What does it mean? Let's check it. Here, we want to send this address to R2 from R1, okay? We should send a BGP update. This is a BGP update with two most important parts. First, NLRI. In NLRI, R1 sets 1000/24. And in the pass attribute of AS pass PA, it sets its AS number. The AS number of R1 is 65,001. Okay, this is BGP update that R1 sent to R2. R2 receives these packets and save the information on its table. For example, we have in R2 a BGP table. Okay, in BGP table, BGP table is same as the EIGRP topology table. In BGP table, R2 save this information that 1000/24 can be reachable from R1. Next stop is R1's IP address, and then with the AS pass of 65,001. Okay, this is the BGP table of R2 after receiving the first update from the R1. And then, because we have neighborship between R2 and R3, BGP neighborship, R2 should send this BGP update to the R3. Look at here. R2 generate a BGP update and sends it to R3. NLRI is the same, but AS pass now incremented to this AS pass 65,002, 65,001. This means that R2 says to R3, if you want to reach to the NLRI of 1000/24 from me, you should traverse 2 AS. One, 65,002, that is my AS, and second, 65,001, that is the R1 AS. And now in R3, we have this entry in the BGP table, 1000/24 from R2 next hop, and AS pass is 65,002, 65,001. Okay, this is a simple process of BGP update advertisement. Now you can understand a little more about the BGP update. We should learn many pass attributes. For example, we have some other attributes beside of AS pass, but AS pass is one of the most important pass attributes that we are using in the BGP. Now I want to show you another example of BGP, and after that we can experience and we can understand other usage of AS pass attribute. This is good for us. Let's do it in this page, first I remove this part. Look at here. I want to draw a scenario, and after that I show you one of the most important usage of ASPath. Look at here. We have, for example, some AS here. Here, one AS, and again another AS. Okay, and another AS here. And then one AS, for example, this is one AS, and also one AS here. This is our example. Maybe you use any examples or any instance of BGP, but I want to use this example for understanding the BGP ASPath function. Okay, we have 4 AS in this scenario, and then as you can see, or maybe we can another AS here. Okay, it's good, and this is another AS. The connectivity between this AS are this connectivity. First we have R1. R1 is a router, is an edge router, and then here we have R2 and R3, also R3. Okay, and then R4. Here is R4, for example, and then R5. This is R5, and one router name is R6 here, and finally R7. This is our scenario. You know that R1, R2, R3, R4, R5, R6, R7 are the edge routers of AS, of other AS, okay, of their AS. This is AS1, AS number is 1 for this AS. This is, for example, AS2, and then we have other ASs. Here is AS3, or we can use AS1, 2, 3. Okay, it's okay. And then we have AS4 here, and then AS5. Okay, this is our scenario. The connectivity in this scenario is done with these links. R1 connected to the R2. This is the connectivity of R1 to R2, for example. And then we have connectivity between the R5 and R6. And again, between the R7 and R3. Look at here. Here, R7 and R3, yes. And then we have other connectivity between, for example, R6 and R3 here. And also we have connectivity between R2 and R3. R2 and R3 in this fashion here, and another between R4 and R5, and finally between R1 and R4. This is our network. Okay, and we have a subnet, for example, net A in R1. I want to show you how we can send this update to other routers, and after that, what is the function of BGP. You are now understanding the process of advertising BGP update and the change in the ASPath attribute and the usage of ASPath attribute. Look at here. First, we have a BGP update. In BGP update, we have NLRI as net A, and also one attribute, ASPath attribute, that is set to 1 because this packet is sent from R1 that is in AS1, and this packet sends to R2. After that, R1 should send these packets also to R4 because R4 also its neighbor. And now the packet reaches to the BGP update packet reaches to R2 and also R4. Then R2 and R4 should send the packet to its directly connected neighbor R3. Look at here. R2 sends its packet to the BGP update to the R3, but doesn't change the ASPath. Why? Because the AS path of R3 and R2, both of them are same because both of them to reach to net A should only pass one AS1. And again, when R5 sends this update to R4, R4 sends this update to R5, doesn't change the AS path, okay? Because R5 and R4 can reach to the net A with one AS1, AS number 1. And then you can see here that R5 sends this update to R6, okay? In R6, we receive the update, but AS path now incremented to 3.1. This means R6, if you want to reach to net A from my side, you can pass first AS3 and then AS1. R3 keeps this packet, keeps this information, and sends to R3 other updates. Look at here. Here, R6 sends this BGP update to R3, and R3 receives another update from R6. AS path incremented to 4.3.1. Now R3 in its BGP table have two information. In BGP table of R3 for net A, two information are available. One from R2 and another from R6. From R2, it receives this information. AS path is 1. AS path is 1. But from R6, it receives this information. AS path is 4.3.1. Okay? We have a special rule in BGP. For using the best path, for selecting the best path selection rules indicate that the route with the shortest AS path is better path. Shortest AS path is better. Because of that, R3 between these two routes to net A choose the routes received from the R2. This means that R2 selects R2's path, R3 selects R2's path as the best path. And after that, the best path should advertise to other router, for example, to R7. Because of that, R2 sends the BGP update to R7, and R7 now can learn the AS path from R2 is 2.1. This is the process of sending BGP update and selecting best path in BGP. Now you understand another interesting usage of AS path attribute. We can use AS path for best path selection. This is one of the functions of the AS path. AS path has some functions, but one of the functions of the AS path is the best path selection rules. How the shortest AS path is the best path. Okay, and also you saw advertisement of BGP update in this scenario. I think it's so easy because only we need to increment AS path attribute number, and it's so easy. Okay, let's continue. In this scenario, we experience two types of AS path behavior. In some of the paths, for example, between R5 and R6, R5 increments AS path. Look at here. R5's AS path is 1 to reach to net A, but when sending this update to R6, it increments the AS path. But when R4 sends this update to R5, it doesn't increment the AS path. Why? Because in the same AS, we don't need to increase, we shouldn't increase the AS path. Because of that, we have two types of behavior in BGP. One type of behavior in BGP is inside of the network, and other types in between the AS. Inside of the AS, between the AS. Inside of the AS, we use the behavior of BGP that is called IBGP. And between the networks, we are using the behavior of BGP, some kind of behavior of BGP that we call it EBGP. IBGP and EBGP. IBGP and EBGP is the abbreviation of external BGP and internal BGP. Maybe you ask me that BGP is an exterior gateway protocol. Why we should use BGP inside of the AS? Here there is an important note. Look at, we use IBGP between R4 and R5 inside the network, but for advertising external networks, we don't use BGP inside of the networks intra of AS for advertising intra networks, for example, internal networks or IGP networks. Okay, BGP can be work inside of AS or intra of AS, but for external network, it's okay. You can use BGP for advertising external networks between two internal router. It's okay. We didn't use BGP inside of the AS for advertising internal routes. We use it for advertising external routes, and this is okay. Okay, very good. We have two types of behavior of BGP. First, EBGP, external BGP. This means that BGP is working between external routers that are not inside an AS, but they are inside of other AS or different AS. For example, R1 and R4. It's okay. And maybe another example is between R1 and R2 we are using now EBGP. But between R3 and R2 we are using IBGP. And again between the R3 and R4 we are using EBGP again. And then between for example, R6 and R5 we are using EBGP. Okay, it's okay. And then again between R3 and R4 we are using EBGP, external BGP. Okay, very good. We have some similarities between EBGP and IBGP and some differences between IBGP and EBGP. We should talk about all of these similarities and also differences. But for now, you understand the different behavior about the AS pass attribute in EBGP and IBGP. In EBGP, we should increment the AS pass number, and in IBGP, we don't increment AS pass. Okay, look at here. In IBGP, we don't increment. In EBGP, we increments. We will talk about EBGP and IBGP in many concepts and configuration. But for the start, first we start with the EBGP, and then after some explanation about the EBGP, we will talk about the IBGP or internal BGP. Okay, very good. Now you understand one of the important function of the AS pass. I want to show you another usage of AS pass attribute that is so important for us in the future topics. Let's explain it here in this picture. Look at here. I want to show you another example and using the AS pass for an important function. Look at here. Maybe I want to clear the picture for you to better understanding. Okay, here. Look at here. We have 4 AS. This is AS1. Okay, AS1. And this is AS2. And also this is AS3. And again AS4 here. Okay. And we have some routers here. For example, in the AS1 we have R1 and R1 connected to R2 in AS2, and also we have R3 and R4. Here is R3 that is connected to R4. And also, beside of this connection, we have a connection between R2 and R3. Okay, between R2 and R3, a link between R2 and R3, and also a BGP connection. Look at here, so easy. R2 and R3. And finally, between R1 and R4. Okay, this is our scenario. First, we have BGP, EBGP between these routers. Here, EBGP connection, and again here EBGP, another EBGP, and here EBGP, and also again EBGP. Okay, this is our scenario, and we want to talk about an important function of ASPass attribute. Second function. The first function of ASPass is bestpass selection, using in bestpass selection, and another function is an important tools that we call it loop prevention. Look at here. In R1, for example, we have net A, and I want to advertise net A, that is 1000/24. I want to advertise these routes to other routers. For example, I use this BGP update. This is my BGP update. In the NLRI, I use 1000/24 with the ASPass attribute of 1. It's okay. You now easily understand it. Okay. And then R2 receive this packet and send it to the R3, because R3 is the neighbor or is the peer of the R2, but increments ASPass to 1. Okay. After this, R3 should send this update to the, for example, R4. Look at here. R3 receives the packet and advertise it to the R4 with the ASPass incremented to the 321. Okay, this is the ASPass. And finally, R4 receives this packet, this BGP update, and should send it to R1, because R4 doesn't know that the packet first advertised from R1 with the ASPass of 4321. You know that R1 now receives this packet. When R1 receives a packet and checks the ASPass, a BGP update, and checks the ASPass and understand and sees that in the ASPass its AS number exists, AS1, R1 can understand that this packet first originated in this AS or first advertised from this AS. Because of that, it does not accept the packet and removes or discards the BGP update. And this means that the loop prevention mechanism is down with ASPass attribute, a many important feature in the BGP. Because if R1 doesn't understand that this packet advertised from itself, from R1 before, it should accept the packet, and again the packet should be advertised, and the packet now, the routing update now is in the loop, routing loop. Because of that, R1 should discard this packet, and R1 discard it. And the loop doesn't take care. Discard the routing update. Okay, this is the second function of ASPass. The first function is the bestpass selection, and the second function is loop prevention mechanism of loop prevention function of ASPass. ASPass has other useful benefits, but we will talk about all of them in the future videos. For now, you understand that ASPass is one of the attributes of BGP and has two functions, at least two functions. One, bestpass selection rules, used in the bestpass selection rules or bestpass selection, and second, loop prevention. Okay, we will talk about other useful functions of this attribute in the future videos. Very good. I think you are now understanding better, or you are understanding more about BGP. But BGP learning is a long way and also easy way. And we should take all of the paths. We should go all of the path to all of the paths that after that we can understand BGP and use BGP. We can understand concepts and then configuration of BGP, and we can use it in many networks, for example, service provider networks or enterprise networks. Okay? For this video, you should review the topics I mentioned in this video. For example, types of routing protocol, for example, the global specification of BGP, and then how the BGP updates are sent between the routers, what is the EBGP, what is the IBGP, what is the NLRI, what is the usage of the AS pass attribute. And after that, you can come with me to the next video for learning other features of BGP.